In this section, we're going to talk about how to simplify complex fractions. So first of all, what is a complex fraction? Well, that's a rational expression, or a fraction, whose numerator or denominator, or both, contain one or more fractions. So we have a few examples here. So we have, I like to call this a mini fraction, and another mini fraction within the overall fraction. So how do we simplify complex fractions? Well, there's two approaches. Sometimes one method is easier, sometimes the other method is easier. So it's best to learn both methods and then be able to apply which one is the easier for that particular problem. So in this first method, what we're going to do is we're going to simplify the numerator and denominator of the complex fraction so that each is a single fraction. And I often use this method when you already have step one completed, or it's very, very easy to complete. So if we have something where it's going to be a lot of work to complete step one, I would go to method two, which we'll talk about in a minute. Then in step two, we're going to perform the indicated division by multiplying the numerator of the complex fraction by the reciprocal of the denominator of the complex fraction. So basically, in step one, we made it so that you have one fraction on top and one fraction on the bottom. And then in step two, we're going to take A over B, which is divided by C over D. And then we can just turn this into multiplication by taking the reciprocal of the second fraction. So we'll multiply and then do any simplifying that's possible. So let's take a look at some examples. In example 1, part A, I have 2 plus 1 over 7 over 3 minus 4 over 7. So 2 plus 1 over 7, I can make that into 14 over 7 plus 1 over 7, just getting common denominators. And then 3 is going to be 21 over 7, and that's minus 4 over 7. 14 and 1 is 15, so that's 15 over 7. 21 minus 4 is 17, so then I have 17 over 7. So now I'm ready to rewrite this as 15 over 7 divided by 17 over 7, and that is 15 over 7 times 7 over 17. I can cancel the 7s, and I have 15 over 17, and that's my final answer. Okay, let's take a look at part B. Here I have x squared minus 9y squared all over x times y, so that's one fraction. And then I have 1 over y minus 3 over x. So I want to combine these into one fraction, so I have to get common denominators. So I'm just going to copy over the numerator because that's all set. And the common denominator is going to be x times y, so I get x over xy minus 3y over xy. And now I can combine those together into one fraction. Now notice that I can factor the numerator here. I'm going to go ahead and do that now. X minus 3y times x plus 3y over xy. And then we have x minus 3y over xy. Okay. So now I have x minus 3y times x plus 3y over xy divided by x minus 3y over xy and this is x minus 3y times x plus 3y over xy. Now I can change to multiplication and take the reciprocal and do my canceling. And so we end up with x plus 3y in the top, and that's it. So that's my final answer. Okay. Now let's take a look at example 2. Here, in part A, I have 3 over x minus 4 minus 2 over 4 minus x. Now notice that those are the same denominators except for a sign change. And then that's over 2 over x minus 4 minus 2 over x. Okay. So what I'm going to do to combine the two fractions in the numerator together is I'm just going to change this to 3 over x minus 4 plus 2 over x minus 4. So I basically factored out a -1, and then this -1 times the negative there is going to make a plus, and I just turn the order around so it's x minus 4. In the denominator, we have two different fractions with different denominators. So the common denominator is going to be x times x minus 4. So my first fraction is 2x over x times x minus 4. And then the second fraction is 2 times x minus 4 over x times x minus 4. Okay. So now I can add together the two fractions in the numerator, and I get 5 over x minus 4. And in the denominator, I have 2x minus 2 times x minus 4 all over x times x minus 4. And let's simplify this expression. Okay, so I have 2x. And then I'm distributing a minus 2, so I have minus 2x and plus 8. And the denominator is still x times x minus 4. And so finally we end up with 5 over x minus 4 all over 8 over x times x minus 4. And now I can write 5 over x minus 4 divided by 8 over x times x minus 4. Change it to multiplication. The x minus 4's cancel. And I have 5x over 8. And that's my final answer for that. Okay, so now let's take a look at B. So I'm going to clear this off because, wow, that took up a lot of space. Okay, so let's try part B. Here I have 2 plus 1 over x all over 4x minus 1 over x. And to combine this into one fraction in the numerator, I'm going to get 2x over x plus 1 over x. In the denominator, I also need x as the common denominator, so that's going to be 4x squared over x minus 1 over x. So in the numerator, we have 2x plus 1 over x. And in the denominator, we have 4x squared minus 1 over x. So now I'll rewrite that as 2x plus 1 over x divided by 4x squared minus 1 over x. Flip this fraction, turn it into multiplication. Now I can see that I can cancel these x's, but I can also factor that 4x squared minus 1. So let's see what we've got now. We've got 2x plus 1 over 4x squared minus 1. But that 4x squared minus 1 can factor into 2x plus 1 times 2x minus 1. And now I've got another factor that cancels out, and this is 1 over 2x minus 1. Remember, when everything in the numerator is canceled out, there's always a factor of 1 left because we're dividing, right? So that's my final answer. Now in method 2, what we're going to do, which is often a lot easier, is to multiply the numerator and denominator of the complex fraction by the least common denominator of the fractions in both the numerator and the denominator. And then you'll simplify. So let's take a look at what that would turn out to be. So in part A, here this is a little different. We've got negative exponents. So I have a to the negative 3 plus b to the negative 1 over a to the negative 2. And so you have to be careful here. I can't move this a to the negative 3 to the denominator because it's a term, not a factor. I can move factors around, but I can't move terms around. So that a to the negative 2, I could move to the top if I wanted to. I'm not going to, and you'll see why. So I'm going to rewrite each of these without negative exponents. So that means I have 1 over a to the positive 3 plus 1 over b to the positive 1, and then that's 1 over a squared. So I just do that within the term, make a fraction. Then I look at what is the LCD. So the highest power of a is a to the third, highest power of b is b. So now what I'm going to do is multiply the numerator by that least common denominator over 1. And do the same thing with the denominator. Okay. So now I distribute this, and I have 1 over a to the third times a to the third b over 1. And then plus 1 over b times a to the third b over 1. And in the denominator, I just have the one fraction. I don't have to distribute, I'm just multiplying. So I'm going to go ahead and say a to the third divided by a squared gives me an a. So in the denominator, I have ab. I've already eliminated the fractions in the denominator. So in the numerator, a to the third cancels with a to the third, and I have b plus b's cancel, a to the third, and that's over a times b, and cha-ching, there you go. So it looked pretty complicated. Turns out pretty easy. All right, now in b, I have 5 over x squared minus 2 over x, and that's over 1 over x plus 2. So my common denominator, my least common denominator, is going to be x squared. And remember, this 2 is 2 over 1. So I'm going to multiply both the top and the bottom by x squared over 1. So I have 5 over x squared times x squared over 1 minus 2 over x times x squared over 1. And in the denominator, it's 1 over x times x squared over 1 plus 2 over 1 times x squared over 1. And now we simplify. X squareds cancel, and I have 5 minus x goes into x squared x times, and I have a 2x left. X goes into x squared x times, and that's a plus 2x squared. Now notice there's a common factor of x in the denominator, but if I did factor, I wouldn't be able to simplify, so I don't need to factor. And that's my final answer. All right, a couple more. Here we have, in part A, x to the negative 2, y to the negative 2, over 5x to the negative 1, plus 2y to the negative 1. So just like the other problem, I'm going to rewrite these without negative exponents. So in the numerator, I get 1 over x squared y squared, because there's only one term there, so they can go to the denominator together. All right, in the denominator, I have two separate terms. So I'm going to get 5 over x plus 2 over y. And at this point, I want to figure out, well, what is the LCD of all of these individual terms? Highest power of x is x. Highest power of x is 2. Highest power of y is also 2. So our least common denominator is x squared y squared. So I'm going to multiply both the top and the bottom by x squared y squared. You can put that over 1. And in the numerator, we have 1 over x squared y squared times x squared y squared. That just equals 1. In the denominator, I have 5 over x times x squared y squared over 1 plus 2 over y times x squared y squared over 1. And so let's see, what is this going to be? 1 over, x goes into x squared x times, and I have 5x y squared, plus y goes into y squared y times, and I have 2x squared y. Again, I could factor the denominator, but I'm not gonna because it's not going to allow me to do any more simplifying. All right, one more problem. Here I have 3x to the negative 1. I'm going to go ahead and just rewrite that as 3 over x. Plus 3y to the negative 1. So I'm going to make that 3 over y. And then that's all over 4x to the negative 2, which is 4 over x squared, minus 9y to the negative 2, or 9 over y squared. So let's see, what's the LCD? Again, it's x squared y squared. Okay, so I'm going to multiply my numerator by x squared y squared over 1, and my denominator by x squared y squared over 1. So the reason why I'm writing out that fraction over 1 every time is just to keep straight what's in the numerator, what's in the denominator. All right, so now I have 3 over x times x squared y squared over 1 plus 3 over y times x squared y squared over 1. In the denominator, I have 4 over x squared times x squared y squared over 1 minus 9 over y squared times x squared y squared over 1. Okay. Let's see what we can simplify. X goes into x squared x times, so that's going to be 3xy squared, plus y goes into y squared y times, so that's 3x squared y. In the denominator, the x squareds cancel, and I have 4y squared, minus y squares cancel, and I have 9x squared. So here I have, I can factor, and it looks like I'm going to be able to do some simplifying when I do that. Okay, so I just shifted up so that we have a little bit more room to work with. Let's see what I can factor. I've got a 3 in common, I have x in common, and I have a y in common in the numerator. So that's going to leave me with y plus x. And 4y squared minus 9x squared factors into 2y plus 3x and 2y minus 3x. Okay. Well, we weren't able to do any simplifying there, but it's always a good idea to check and see if that's going to be possible. So that's my final answer. The end.